Hi, everybody. Today we're doing 2.6, and that's differentials. So we're going to introduce the idea of increments and differentials. Now, the truth is, these are things we know already. They're just different names for stuff we already know. So don't get too, don't get too worked up about this. And basically, the increment is the change in x or the change in y, and the well, that was do that first. So let's say you have a function y is equal to x to the third power, y equals x cubed, and x changes from 2 to 2.1. X goes that distance. Well, the increment of x is going to be what the x moves, so it's going to be 0.1. So it's going from 2 to 2. How did I figure that out? By subtraction. You subtract 2.1 minus 2 gives me 0.1. That is the change in x, and that is what we call the increment of x. It's, or sometimes we call it delta x. Change in x, increment of x. These are three ways of saying the same exact thing. It's just three words for the same thing. So don't get stressed out about this. It's just a lot of different words for the same thing. And it's basically stuff you know already. Now, meanwhile, when x goes from 2 to 2.1, well, y is going to go from 8 to 9.261 because 2 to the third power is 8, and 2.1 to the third power is 9.261. And the increment of y, you guess it, is going to be 1.261. Why? Because all you do is subtract. You subtract the final y value from the initial y values. So 9.261 minus 8 gives me 1.261. And that's the change in y, which is the increment of y, which is delta y, which is whatever you want to call it. Same thing. Okay. That's good to know. Okay, and here we go. Here's the official definition. So when if x is equal to x2 minus x1, which means x2 is equal to x1 plus delta x, or plus a change in x, or plus whatever you want to say, delta y is going to be y2 minus y1, and y2 is f of x2, and y1 is f of x1. And notice that f of x plus delta y, delta x, minus f of x1, that is delta y. So all of this stuff is just taking this is basically taking something very simple and just giving you tons and tons of ways of saying something that's very, very simple. Am I implying that this is overcomplicating something that's very simple? I'll let you figure that out. So anyway, delta y corresponds to the change in y, but y is just reacting to a change in x. And delta x, of course, could be positive or negative, whether x is going up or going down. That's just the way it is. So, alrighty. So, okay, moving on. Let's look at an example. So we have y is equal to f of x, which is x squared over 2. So you want to find delta x, delta y divided by delta x, which, by the way, that is the differential. Get it? So the y increment divided by the x increment is a differential. Notice a differential is a lot like a derivative. I mean, it looks a little like a derivative. We're going to see it acts like a derivative, and what can I say? And at x1, x is going from 1 to 2. x1 is 1, x2 is 2. So let's find all these things. Well, delta x, of course, is just 1. That's easy. And we also want to find f of x1 plus delta x minus f of x1 over delta x for these values of x1 and delta x is equal to 2. Look at that, delta x equals 2. That's very interesting. Okay. Anyway, to tackle the first one, delta x is just x2 minus x1, which is 2 minus 1, which is 1. So you can tell all your friends that you learned in college that 2 minus 1 equals 1. This beverage is non-alcoholic, maybe. So delta y is f of x2 minus f of x1. And that's just going to be f of 2 minus f of 1, which is 2 squared divided by 2 minus 1 squared divided by 2, which winds up being 3/2. And finally, delta y divided by delta x is just 3/2 divided by 1, which is 3/2. Now this here, notice this looks a lot like a derivative, and that's not, that's really why we're doing it. So this is f of 1 plus 2, because x1 is equal to 1, and we said in this example, in part B, delta x is equal to 2 minus f of 1 over 2. So this is f of 3 minus f of 1 divided by 2. F of 3 is 9/2 minus 1/2, which is 4, which is 8/2, and 8/2 divided by 2 is 4/2, which is 2. So this just equals 2. Whoopee. Let's move on. Okay. And notice that in a derivative, this guy here would be h. Now we're calling it delta x. It's very, it's similar, pretty much the same idea. Okay, let's carry on. Now differentials. Differentials, well, it's basically when you take the y increment divided by the x increment, that's your differential. So let's just move over here. Differential. So if y equals f of x, then the differential, which sometimes we call it dy or sometimes we call it df, is defined as a product of f prime of x and dx, with dx equals delta x. So symbolically, dy is equal to f prime of x times dx, but dx, of course, is just going to be delta x. Or sometimes we'll just write it df. Sometimes because f and y are interchangeable. F of y equals f. Let's look at an example of this. So all this stuff, all things are usually easier when we have examples. So find dy. Find dy for f of. By the way, this having my beautiful face here, my handsome face. I just want to say that. It's actually sometimes gets annoying because somehow like I always have to be moving it out of the way. So I'm just saying that. Okay, enough chit chat. Let's look at this. So find dy for f of x is equal to x squared plus 3x. Evaluate dy for x equal 2 and dx is 0.1, x equals 3, so on and so forth. So dy is f prime times dx, which now f prime that we know from derivatives, that's 2x plus 3. So that's in parentheses times dx, and dx is equal to 0.1. So booyah. Okay. I don't know why it doesn't. Oh, so when x is equal to 2 and dx is equal to 0.1, you just plug in 2 for x and 0.1 for dx, and you get 0.7. In other words, notice what I'm trying to say is that this part right here, these first 2 lines here, that's going to be for all the problems, A, B, and C. Now all we got to do is just plug in the different numbers. So here I'm plugging in 3 for x and 0.1 for dx, and I'm getting 0.9. Here I'm plugging in 1 for x and 0.02 for dx, and I'm getting 0.1. So basically you take the derivative and then you just plug in whatever you got to plug in. That's basically the way it is. That is the way it is. That's how it goes. Okay, and for this one, it's problem. Oh, that's it. Moving on. So we have so when we have the symbol dy dx, we can look at it as a derivative, f prime, and then just put an f prime of 2, and we get 7. In this example here, x squared plus 3x, or with differentials, we can look at it as a ratio of the differentials, and we get 0.7 divided by 0.1, which is also 2. And okay, let's no, hold on 1 second. Let me just let's go on. But in this fraction here, where did the 0.7 come from? Where did the 0.1 come from? Well, the 0.7, we're looking at x equals 2 and dx equals 0.1, which is the same thing in part A up over here. So when in part A, we wound up getting that dy is equal to 0.7, but we want dy divided by dx. So that's 0.7 divided by 0.1, which is dx, and that comes out to 7. So notice that both of these ways, whereas here I just took a derivative and plugged in 2 and I got 7. So notice you want to get in the same answer, but they're two kind of different two interpretations, if you will. We can also make approximations using differentials. So delta x is approximately f prime of x, and delta y is approximately f prime of x times delta x. So also, since dy is equal to f prime of x times dx, So delta y is approximately delta x, because you just substitute and that's what you get. So dy can be used to approximate delta y. I guess vice versa also, but dy is, you could figure out algebraically. And let's look at an example of how that works. Let's look at an example of how that works. Okay, y is equal to f of x, which is 6x minus x squared. So we want to find delta y and dy when x equals 2. So that first, then we'll go to part B. So delta y is equal to f of 2 plus delta x minus minus f of 2. I'm sorry, and this is 6 times 2 plus delta x minus 2 plus delta x squared, because that's what the function is. Minus 6 times 2 minus 2 squared. So this becomes, so if you just collect everything and simplify everything, you get 2 delta x minus delta x squared. Now, f prime of x is 6 minus 2x. F prime of 2, if you just plug in 2, you get 2. So dx is equal to delta x, and dy is f prime of 2 times dx, which is 2 times delta x, which means I could plug that back into which means I could plug that back. So what does that mean? So that's it. Actually, that's sorry. That's it. We're done. Now for B, compare delta y and dy from part A for delta x equals 0.1, 0.2, and 0.3. So basically make a table, you get those values, and pal, you're done. Very nice, very beautiful, very simple. And we figured these out the same way we figured everything else. So let's move on. Cost revenue. A company manufactures and sells X microprocessors per week if the weekly cost and revenue equations. By the way, if I ever go over a problem too quickly, or you want more detail or anything like that, sometimes it's a difficult blend when you do this, because sometimes if you over explain, that's just as bad as under explaining. Because if something can be explained in 5 words and you use 500 words, it makes it much more confusing and much harder for the person to get what you're saying. So I try to be brief, but if you're too brief, then you guys will be lost. And if I'm too wordy, you're gonna be lost. So if there's ever a time when you want me, we don't get something, just contact me, email me, call me on my cell phone, whatever, whichever. And it's very, I just want to repeat, and I've said this a bunch of times, I'm saying it again, I am a human being. That's why, by the way, the reason I put my picture here, the reason, is because I want you to realize that I am a real, actual, live human being, and this is not a video that was made 20 years ago. This is a video that this is August of 2021. This is not a what's I'm trying to say. I just want you to know I am an actual human being, and you can call me, you can email me, you can text me, whatever. That reminds me, I'm gonna just put all that stuff on the on Canvas now. So let's meanwhile, but let's just finish this up, and then we'll go from there. Okay. Or let's say there's a homework problem that you just can't figure out how to do. You tried and you looked at all the clues that the sell, and so you could email me about that. Either I'll explain it to you, you can call me and I'll explain it to you, or I can just make a special video. I've done that before. Sometimes someone will say, hey, I don't get problem number 7 on this homework on section 2.5, whatever, and I can make a whole video just on that. You see what I'm saying? It's not. This is we're an interactive live class, even though we're not kind of live. I mean, we're alive, but we're not. You get what I'm saying? Anyway, y is equal to f of x minus 6, which is equal to 6x minus x squared. Oh, sorry, I did this already. Whoops. Cost revenue. a company manufactures and sells X microprocessors per week. If the weekly cost and revenue equations are C of X is 5,000 plus 2X, that's the equation that tells you the cost. R of X is equal to 10X minus X squared over 1,000. Remember, cost is what it costs to make this thing. And R, that's C for cost, and R revenue is how much money you take in. Profit, by the way, which you're not asking, I'm just telling you, profit is R minus C, revenue minus cost. Anyway, then use differentials for to approximate the changes in revenue and profit if production is increased from 2000 to 2010. So if I'm making 2000, I'm going to increase to 2010. That's going to change the revenue. It's also going to change the profit. And by the way, just because the revenue goes up doesn't mean the profit's going to go up. You know, it's a funny business. You know, because sometimes when sometimes if you make too many something, or if you wind up losing profit, and sometimes if you charge too much, you actually wind up losing profit. There's a thing, I forgot what it's called, Africa or something like that, where if you charge too little, obviously you're not going to make enough money. But if you charge too much, you're going to drive away your customers, and you're going to, make less money that way also. So it's like and again, we're going to learn in this course how to figure out that sweet spot. Anyway, so we're going to approximate delta R and delta P piece for profit with DR and DP, and we're going to use X is equal to 2000 and DX is equal to 2010 minus 2000, which is equal to 10. So DX is equal to 10, and RX is equal to this guy. PX is equal to R minus C. So it's this whole guy right here. DR is equal to R prime times DX. So I just have to take the derivative of this sucker and times it times DX, which is 10. And that becomes, that's just, and plug in 2000 for X. And I want to gain $60 per week. That's my, that's the change in revenue. And the for P, I take the derivative of this longer guy, and I get 8x. Oh, sorry, 10x minus 2x gives me 8x. The derivative is 8 minus x over 500. Plug in 2000 for x and 10 for dx, and I get it winds up coming down to 40. So even though the revenue goes up, even though you're making $60 more, you're only profiting $40 more. So that's that's just the way it is. Then that's kind of to be expected. And that's it. That concludes 2.6. It's been loads of fun, and I'll see you guys on the next video. Bye, everybody. Bye.